Everybody, it's Tyler here for Behind the Bot, where we look into FTC robots and what makes them work. And joining me today, I have 11970 Titanium Talons coming out of Washington State. They just competed at the Washington State Championships, where they're semi-finalists there, and reached their high OPR of 117.3. You can also catch them in just a couple weeks at the Alabama State Championships. What a trip and travel that we look forward to that as well. And joining me from Titanium Talons is going to be Nick and Dariush. And we're going to be doing a full overview of this robot, some cool software things to overlay. I'm really looking forward to hearing about their capstone mechanism and their shared hub score. All this and more coming up on Behind the Bot. Your destination for first content, updates, and gaming.
Welcome to the fun.
First Updates Now is supported by Stryker Careers. Apply the skills you gained as a first student or mentor and help change the world at Stryker. Stryker is the top career choice for many of those in first because of their commitment to innovation and saving lives. Learn more about the incredible culture at Stryker and view their thousands of positions available around the world at careers.stryker.com. So let's start out with the intake of your robot. We'll kind of follow that scoring path of both the cargo and the boxes on it. So we'll start with your intake and tell us more about mechanically what went into it, and then we'll talk about some of the software on each part of the robot as well.
Yeah, so I'll start off by showing our intake off. We use some side compliant wheels here, as well as this overhead surgical tubing you can see here. We found a single flap actually made it the most consistent overall, as more flaps just kind of got jammed up in our system. So I can press our intake button here. That'll bring this house, which is what we call our storage system, down. Then I can put something in like that, and it will go right into our robot. Now I just press another button on my controller, and it grabs it and pulls it up. Now I'm going to put our slides up. So I press another button. This uses a preset to score, and it brings our slides all the way up like that. And then I just press one button and bring it back down to score out the back. Now we have another scoring path on our robot. So I'm going to intake another piece of freight here, and it will go straight into our intake like that. And then I can score into the neutral goal using a conveyor belt like thing that's kind of similar to a treadmill. So I press one button here, and it comes straight off the back and allows us to score really easily in the shared goal and really efficiently. As well as for endgame tasks, we have two main things. So if you look in here, I'm going to take off our number plate really quick. You can see it behind the wiring. You can see our servo carousel spinner in there. So we use a servo and a through-bore encoder to track its position on a 1:2 gear ratio. And I can just press one button real quick, and it will spin our carousel 20,000 ticks of that encoder to allow us to keep track of where we are and get a really efficient duck. So we can spin 9 ducks and get our park in 19 seconds. And then another thing we do towards the end of our endgame period is we move our capstone mech, which uses a tape measure right here to move around. And then we can extend it here to score our team shipping elements. And that's kind of a general overview of our robot.
Well, let's break down a little bit a couple things that you mentioned first, if you don't mind. So starting out with your intake there, I want to talk about the little surgical tubing piece that you have in the front there. Can you tell me a little about what was kind of the concept behind that? And then was that the first thing you went with, or did you kind of try different iterations of what you went through? And how's it been performing?
Yeah, so we started off with just these side compliant wheels on here, and we found that there became a point where we would just get stuck and be unable to get into the pit, and there was like 15 elements left there that we just couldn't grab. So we added the surgical tubing, which inside there's a piece of TPU. You can't really see that super easily. That gives it a little bit more stiff overall, so that we can spin and grab things from like all the way out here. So if I run it, oh, I'm on the wrong controller. So I can just grab from super far away like that. It will allow me to put it in really easily.
And then as we kind of continue through, I'm curious to hear more about on the strategy behind having the shared hub specific score on there. What made you want to actually have like something different than what your typical linear slide mechanisms were?
Yeah, so actually a rather interesting story behind that mechanism. This piece was initially a piece of Teflon that we had used, and it was actually never intended to be used for the shared goal. We actually were originally using it as a mechanism to score on the low randomization for auto. But then we found that, so this was initially driven, so it started as a piece of Teflon, and then it became a core hex driven treadmill. And then we switched back to Teflon because it was too slow. And then we realized that Teflon was inconsistent. We had like a static Teflon ramp, and then and then we switched to an ultraplanetary when the perpendicular gearbox came out. It made the profile fit really nicely. And Now it's just a very elegant both for low and shared.
No, I love having the thought process of the separateness on that, and clearly it's worked out quite well for your team so far. And Dariush, I don't mean to not leave you out on there. So talk to me a little bit about some of the automation, sensors, programming that's gone into these scoring mechanisms.
Yeah, sure. So some of the automation stuff that we've had. So we have done a lot of iteration this year over some of the control systems we've used on this robot. So we started our year with odometry wheels in the back, and we had a servo system to pull them up and keep them down when we needed them for auto. We found it to be too much maintenance work and didn't yield the auto results we wanted. So we eventually transitioned away from that to drive encoders. And then another system we also tried experimenting with in the early season, you can still see it's mounted on our robot here, this T265 camera here. We experimented with this a lot, and I did some back-end work on the FTC 265 repository, and just did a little bit of collaboration with the teams involved in that. I've been pretty active in the FTC 265 Discord server, but that also didn't work out because a lot of garbage got because of poor garbage collection. We decided it'd be just easier to use the drive encoders, and they've worked out pretty okay for us so far. We're right now developing a cycle auto to bring to Alabama State.
So from your robot, as you start to get ready for Alabama State's coming up, you mentioned a couple changes you're looking at doing. Is there anything else from either programming or mechanical that you want to mention that you're trying to re-implement or make modifications or iterate to?
See, I'll start off that question. So we actually just finished making all of our changes yesterday. You can see these chassis plates out here are actually completely brand new. I just put these on the other day. We made a couple of major changes. So you can see these right here. These are our roller bearings that go against the wall to allow us to roll against the wall and not get stuck in that pesky little gap in between the wall panels. Those were originally 3D printed and bolted into the chassis, but they kept breaking. So we made new chassis plates to integrate them. As well as down here, there is a gap in the chassis so that we were having a lot of problems in teleop where at Washington State, we would drive over a spike and then we'd be stuck, and it would take me as a driver like 15 or 20 seconds to get out of it. So we raised that clearance on the outside plate. So if that happens, then I can just strafe right over into the wall and be fine. So those were kind of like the two major changes we made. On the hardware side, I don't think we have any more changes we're going to make between now and then. And yeah, that's just generally what we've done the last week or so.
Now, how about from a software end? Anything else? Any future implementations you're looking at making?
Software-wise, not much. The biggest thing software-wise is we're looking at writing a cycle auto, as I kind of alluded to, and we're making some pretty okay progress with it. A couple back-end changes I made to improve consistency. I found some. I've been optimizing our PID curve for speed just so we can get those cycles in that much faster, and hopefully we show up to Alabama with a decent cycle auto.
Well, I wish you best of luck, of course, coming in just a few weeks right in the beginning of March here. So looking forward to seeing your performance there. But Nick and Dariush, thank you once again for taking the time to tell us more about your robot. Obviously, good success. I know you want more, right? You want to take a state championship, so we're looking forward to seeing that happening. But wish you best of luck, and can't wait to see your robot perform in just a couple weeks. Thanks a lot, guys.
Thank you.
Thank you.
Thanks to Stryker Careers for their support in this video. First alumni and mentors are making Stryker a top priority for their internships and careers. That's because Stryker knows that those in first are the leaders and innovators of tomorrow. If you want to help make the world a better place by creating life-saving medical devices and technology, get started at careers.stryker.com. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter. And First Updates Now on Facebook, Instagram, TikTok, and Twitter.